Hello and welcome to Vodcast 14.2. In this podcast, I will talk about warm fronts, cold fronts, stationary fronts, and occluded fronts. I'd like to start off by defining what a front is. Fronts are boundaries that separate air masses of different densities. As an example, on one side of the front you might have a continental polar air mass, and on the other side of the front you might have a maritime tropical air mass. The maritime tropical air mass is warmer and less dense than the continental polar air mass. Now, it's very important to note that even as air masses clash and interact, they will retain their identities. In other words, there will be limited mixing of the two air masses. The warmer, less dense air will be forced aloft, and the cooler, denser air will act as a wedge. You may remember from a previous chapter our discussions about frontal wedging, and frontal wedging will always lead to what we call overrunning. With overrunning, warm air will glide up over cold air, and I want to stress that this will always be the case, regardless of the front. More specifically, whether it be a warm front or a cold front advancing, the warm air will always glide up over the top of the cold air. In this vodcast, we're going to focus primarily on warm fronts and cold fronts, and I'd like to start off by talking about warm fronts. With warm fronts, warm air will replace cooler air. On a map, a warm front will be represented by a line with red semicircles, as shown in this image. Now, I'd like to state on the record that you might see this picture and the picture on the following slide on quizzes and tests, and it's very important that you know the defining characteristics for both warm fronts and cold fronts. For starters, a warm front will have a very small, shallow slope, and you see a ratio of 1 to 200. What that ratio basically means is that if you were 200 miles ahead of the surface location of the warm front, you could look straight up in the sky and the frontal surface would be 1 mile over your head. Now, you can't actually see the frontal surface, but the boundary between warm air and cold air would be 1 mile high at your location. It's also important to note that the clouds will gradually become lower as a warm front approaches you. Let's suppose you're in Pittsburgh, Pennsylvania, and as you can see in this image, you're kind of immersed in cold air at the moment. If you look up and see cirrus clouds, that's one of the first signs that a warm front's approaching. Now, that warm front can still be many hundreds of miles away from you, but in the next day or so, that warm front will eventually work its way to you. You can almost imagine that red boundary line is moving its way from left to right across the screen. Gradually, you notice the clouds start to get lower and lower in the sky. You'll see a shift from cirrus clouds to cirrostratus clouds to altostratus clouds, and as that warm front gets really close, you'll start to see nimbostratus clouds, and you may see moderate precipitation. Warm fronts move relatively slowly at speeds of about 15 to 20 miles per hour, and generally speaking, they will only produce light to moderate precipitation. Although in some cases, if we're talking about warm, unstable air, you can see the formation of cumulonimbus clouds as a warm front advances. Now I'd like to overview cold fronts. And cold fronts occur when cold air replaces warm air. On a map, a cold front is shown by a line with blue triangles, as shown in the image here. Cold fronts are twice as steep as warm fronts. That cold air is acting as a wedge, and if it's forcing warm, moist air aloft, you can see the formation of some very powerful storms. It's also worth noting that cold fronts will move faster than warm fronts, with speeds of between 20 and 35 miles per hour. The weather associated with cold fronts is often violent. It can include thunderstorms, high winds, hail, and even tornadoes. However, it's worth mentioning that even though these fronts can produce violent weather, the duration of the weather event and the precipitation is usually short. Warm fronts can produce moderate precipitation that's kind of long-lasting, whereas cold fronts can produce very powerful storms, but they're not long-lasting. Now, after a cold front has advanced past your location, you'll probably notice a temperature drop, and then there will be subsiding air and clearing conditions. Now, just as was the case with warm fronts, one of the first evidences you may see for an advancing cold front is cirrus clouds. The difference in this situation is if you're in Indianapolis, Indiana, you're currently immersed in very warm air. On the last slide, as you may recall, Pittsburgh was immersed in cool air as cirrus clouds started to form. But if you're in Indianapolis and you look up and see cirrus clouds and it's quite warm outside, there's a chance that a cold front is approaching. And one of the first signs that you'll see as that cold front gets really close is the presence of very towering dark clouds. It's also worth noting in this image that if you're in St. Louis, Missouri, you're probably about to get bombarded by a thunderstorm. But if you're in Kansas City, the front's already past you, so if you walk outside, it'll feel a little cooler, and odds are the sky will be clear. Indianapolis, being a couple hundred miles or so away from St. Louis, will have to wait a little bit longer for that cold front to reach them. The last two types of fronts I'd like to briefly overview in this vodcast are stationary fronts and occluded fronts. With a stationary front, the surface position of the front will not move. More specifically, the flow of air on both sides of the front is almost parallel to the line of the front. On a weather map, a stationary front will have blue triangles on one side of the line and then red semicircles on the other side of the line. The final type of front I'd like to overview are occluded fronts. An occluded front occurs when an active cold front overtakes a warm front, and then cold air wedges warm air upward. In the images shown on this slide, you can kind of see the development of an occluded front. In the top picture, we have a cold front running into a warm front, and then to the right of the warm front we have another cold front. At the warm front boundary, we see warm air overrunning cooler air, but as that cold front coming from the left smashes into the warm front, we see overrunning occurring at the cold front boundary, and we see the formation of a pretty powerful cumulonimbus cloud. And you can almost think of this as warm air getting trapped between two cold air masses. When that occluded front initially forms, you will see some very, very heavy rainfall. And although the weather associated with occluded fronts can be very complex, occluded fronts are often associated with strong storms and severe weather. Now, as that cold air coming from the left continues to advance, the occluded front will start to work its way vertically into our atmosphere, and in the bottom image, we start to see the dissipation of that heavy rainfall. Okay, that concludes this video podcast. In our next podcast, I will overview mid-latitude cyclones. And mid-latitude cyclones are the primary weather producers in the mid-latitudes.